Hi there, this is Tony Verbsky again. You can call me Verb if you want. I'm going to go over section 9.2. Well, today we're going to just basically make up trigonometry and then we're going to pay for it the rest of the semester. So here we go. Well, we wanted to study oscillatory motion, you know, like a wheel going around and around, a vibrating beam. I don't know, you could actually just put a ruler on a desk and then pull down on it and watch it vibrate. It's called damped harmonic motion. But we need a little more power. Lines, parabolas, they're all great, but we need something that repeats and keeps going forever so we can get this oscillatory motion modeled by some type of math function. So what you do in math when you don't have enough power, so we're still in the XY axis, but we want something a little more complicated. So what you can do is add some variables, like create some radius on a circle and associated angle theta. Now, we already have an automatic equation. This is x, this is y. By the Pythagorean theorem, x squared plus y squared equals r squared. Or you can actually solve for r, and technically it's plus or minus the square root of x squared plus y squared. But there is no such thing as a negative radius. Therefore, you got one or two equations there, depending on how you look at it. Now, what I'm going to do is I'm going to make up a relationship. I'm going to define sine of theta to be y over r. Why? Well, just because I'm trying to relate theta, y, and r. I already have x related to y related to r, so I might as well just relate theta to y and r and just divide the two. Then I'm going to define cosine of theta to be x over r. And now, because I made those two things up, we pay for the rest of the semester. We got x, y, and r all related. We got theta, y, and r related, and we got theta, x, and r. But what we get is some really cool things just automatically by moving things around. So, by the way, these are defined. I can define things to be anything I want, but you know, algebraically, we hope all this works out. Now, just for kicks, I'm going to try to relate sine with cosine by doing a little simple division. And that's y over r over x over r. I don't know, copy it, dot it, flop it, invert, multiply. Been teaching high school for years and years and years, so we get this. That's a pretty cool relationship, really, because now we got theta related to y and x. So that's so good, I'm going to define it to be something else. I'm going to define this to be tangent theta. Let me, forgot that I was watching Billy Madison. Let me shut off the TV for a second. I should have just used the pause button. Sorry about that. Moving on. Not moving on, I'm sorry. Adding to this, since I'm defining things, I like to define the reciprocal of sine, meaning 1 over sine theta. And I'm going to just call it cosecant theta. And that's just going to be r over y. And I'm going to define 1 over cosine theta to be secant theta. And that's going to be r over x. I think, unfortunately, you know, this starts with an s, its reciprocal is a c, and this starts with a c, the reciprocal is an s. I find that unfortunate, but how my math forefathers defined it. So I have no control over things. And then 1 over tangent theta to be cotangent theta. And that equals y over, excuse me, back it up, x over y. So understand there's just really sine and cosine, and I just made up 4 more definitions. Now, when you do these things, just make things up, you pay. For example, we knew logs existed, but we weren't able to basically find the inverse of an exponential algebraically, so we just said let there be logs. We only paid for a chapter, about a month. This class, because of what we just made up, we're going to pay a whole semester. But the cool thing is we really only work with these 6 functions. So how bad can this class really be? So here we go. Recall. The worst word in all mathematics. You remember just a few minutes ago, x squared plus y squared equals r squared. And we know sine of theta equals y over x, which implies, back her up, sorry about that, y over r, which implies y, multiply both sides by r, is r sine theta. And you know cosine of theta equals x over r, which implies x equals r cosine theta. Just so you know, we'll do that probably about 4 times this semester, this almost exact lecture, but talking about things like vectors and polar coordinates, complex numbers. But anyway, drop in your y and square it, and drop in your x and square it. So instead of x squared plus y squared, we have r cosine theta squared plus r sine theta squared equals r squared. And then laws of exponents still hold. We get r squared cosine squared theta plus r squared sine squared theta equals r squared. Lasso the r squared, rip it out, old school factoring. And what the heck, let's divide by r squared. And we get cosine squared theta plus sine squared theta equals 1. We managed to relate cosine to sine. This is called a Pythagorean identity. Now we can basically use a little bit of trickery and what we know to get 2 more. So what we're going to do is multiply this side by 1 over cosine squared, and we're going to multiply this side by 1 over cosine squared. The 1 over cosine is secant, and you got a 1 over cosine, a 1 over cos, so you get a secant squared. Now, cosine squared and 1 over cosine squared is 1 plus sine squared theta over cosine squared theta. And so you get 1 plus, but you remember it's sine over cosine, and we remember, yeah, right, we just learned it a second ago. Sine over cosine is tangent. Yeah, granted tangent's y over x, but tangent's also sine over cosine. So we get tangent theta, but it happened twice. And then by a similar trick, I'm not going to do it in front of you because I'm going to multiply both sides by up here, 1 over sine squared, and we're going to get cotangent squared theta plus 1 cotangent squared theta, giving you the 3 Pythagorean identities. Everybody who leaves this class knows those identities. Everything I have written, like tangent y over x equals sine theta over cosine theta, all that, everybody remembers everything that's on the paper. So get on it, start memorizing it. Okay, let's put this to work. If you would go, let's say 1, 2, 3, negative 1, 2, 3, 4. So you get this point, negative 3, 4. Some point x, y. But if you want to be in this class, there's more. There's associated terminal side. So we're talking about an angle where the terminal side lies in the second quadrant. And there is an associated radius. Now you can think Pythagorean theorem, or you can just memorize the radius formula is the square root of x squared plus y squared. And the radius is the square root of negative 3 squared plus 4 squared, square root of 25 plus 5. I don't know what the angle is, but it doesn't matter because my question is evaluate sine theta, cosine theta, tangent theta. Now I just made the stuff up, so y over r, x over r, y over x. I'll answer these questions all day long because you got x to be negative 3, you got y to be 4, and you got r to be 5. So you may not understand what you're doing, but I don't always need to understand what I'm doing. Just give me some formulas. Y is 4 over negative 3. Boom, boom, boom. Hey, you want to score some more points? Do cosecant theta. Do secant theta. Do COT theta. Reciprocal, reciprocal, reciprocal. 5 fourths, 5 over negative 3, negative 3 fourths. Boom. I call that, give me the 6. Evaluate all 6 trig functions for me. Now, do I understand anything? No, not really, but I don't let it bother me because I know we'll put it all together down the road anyway. Just so you know, I selected the problems, and this book has a pet problem, so I try to avoid it, but I'll do this one because it's a good review. X plus 2y, so this is example 2. It's actually in your textbook, so sometimes I'll change the problems, like last time I changed the problem. This is exactly example 2, so you won't have to do as much reading. And they go, find the 6. The 6. And they want you to answer sine theta, cosine theta, tangent theta, and then the 3 reciprocals. I don't want to do that right now. It's the question that's weird. Because I know you can isolate y, so y equals negative x divided by 2, which really is negative 1/2 x plus 0. It's the equation of a line that has y-intercept, it has y-intercept 0, and you go down 1 over 2, up 1 over 2, and you're wondering what angle they're talking about. What the book says, x is positive. This is the positive x-axis. This is the negative x-axis. So what you want to look at is the positive side, which means don't look over here. So really, they're talking about that angle in the 4th quadrant. Well, I happen to know that x equals 2, y equals negative 1, and the radius is the square root of 2 squared plus negative 1 squared equals the square root of 5. So I can answer the 6. Sine negative 1 over the square root of 5, cosine 2 over the square root of 5, and tangent negative 1 over 2 because it's y over x. Unfortunately for you, we must rationalize. You get really good at this. Minus the square root of 5 over 5, 2 square root of 5 over 5, and then the reciprocals. Now this is starting to look a little scrunched up here, but I'm going to continue anyway. The reciprocal of sine is cosec. Excuse me. Don't take the reciprocal of this. Take the reciprocal of this. Minus the square root of 5. Secant theta. Don't take the reciprocal of something you rationalize. Go back and flip over the thing before you rationalize. And then cotangent theta. 2 over negative 1. Nobody really cares where the negative goes. Down low, up front, on top. It's all good. All right. So those are some good questions. Now we got to work on some basic evaluations. You got to understand, I don't know what the angles were in this problem here. I don't know what that angle is. And didn't know what that angle was. But what I want to do is work with some angles I know. So what we traditionally do for a 90-degree angle, we just pick the point 0, 1, meaning terminal side, initial side. We all know theta equals 90 degrees. And you'll recall from yesterday, it's equivalent to pi over 2. Yesterday, whatever day, this is online. I don't know when you actually looked at it. Anyway, that's really pi over 2 radians. Remember, we want to become radian fans. But anyway, if I do sine of 90, you're like, wait a minute. It's y over r. Y is 1, but what's the radius? Well, I don't even see a circle. Yeah, you do. Here. Now I see the circle. But the weird thing is the radius equals 1. So it's 1 over 1 is 1. So sine of 90 is 1. Cosine 90 is x over r. So it's 0 over 1 is 0. Tangent 90 is y over x. So 1 over, 0 undefined. Cannot divide by 0. Graphically usually means vertical asymptote, some type of hole, some type of junk. I'll tell you in this case, it is a vertical asymptote. And then obviously there's the 3 reciprocals. But the reciprocals are not as obvious, I should say. For example, cosecant of 90. What's the reciprocal of 1? 1. That one's easy. Secant of 90, on the other hand, the reciprocal of 0 over 1 is 1 over 0, therefore it does not exist, or undefined. Cotangent 90 is the reciprocal of 1 over 0, which is 0 over 1, which is 0. Now, in your book, there's a table of angles table, and it has 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees, and they generate it playing this same game. Just put the dot at the 180, put the dot at the 270, put the dot at the 360, play it over and over and over and over again. I am not a believer of the table. I do not memorize the table because we're going to have the graphs coming your way. Now, just so you know, this book does graphs early, but it may not be early enough for us. Whoa. Hopefully my thing's still working. Woo. Okay. So, just know I'm not a table guy, but I'll play that game, you know, as long as I have to play. It has to be 90, 180, 270, 360. I'll do it over and over and over again. Okay. Now, we do need to create a mnemonic device. So, this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. This is the plus plus quadrant, x is plus, y is plus. This is the minus plus quadrant, the minus minus quadrant, and the plus minus quadrant. Now, we learn that we could do this for all 3 of them. So we'll write all down, all 6, what the heck. Sine of theta, y over r, cosine theta. See, I know all these. You need to know them like this. Tangent theta, y over x, and the other 3. But let's not ignore them. CSC theta, cosecant, r over y, secant theta, r over x, cotangent theta, x over y. I'm going to focus on the first 3 though. Now, in the first quadrant, x and y are positive, but guess what? A radius is always positive. A radius is always positive. A radius is always positive. And a radius is always positive. In quadrant 1, sine is plus because it's plus over plus. Cosine is plus, so it's plus over plus. And tangent is plus because y is plus and x is plus, so therefore all 3 are positive. They're all positive. And I don't just mean sine, cosine, tangent. All 6. But let's focus on the 3. Now, in the second quadrant, it turns out that sine, once again, is y over r. Positive over positive is positive. And then tangent is, oops, sorry. No, sine is positive. Sine is positive over positive, therefore sine is positive. But the other 2 are negative. Because cosine x is negative over positive is negative, and positive over negative is negative. So you know what? Just sine is positive. But if sine is positive, that means cosecant's positive. And the other two are negative. Once again, let's keep the focus here. Now, in the third quadrant, the only positive one is tangent. I lied. Cotangent is also, but I'm not looking there. Because y over x is negative, negative, double negative gives me positive. But since x and y are positive, these are negative, and of course, these are negative. And then finally, in the third quadrant, only cosine is positive. So what we have is the mnemonic device, all students take calculus. So here's how it works in real life. You want to know where the 6 trig functions are positive and negative. So you go, all students take calculus. So let's talk about sine. Sine is positive in the first and the second, and negative in the third and the fourth. But sine and cosecant have the same sign chart. Cosine is positive in the first and the fourth, and obviously negative in the other two, but its buddy secant has the exact same sign chart. Tangent is positive in the first and the third, and correspondingly negative in the second and fourth, but tangent and cotangent have the same sign chart. Now, all this will be easier to understand once we get the graphs, because you can understand what's positive and negative when you're looking at a graph. But right here, all students take calculus has worked for years. Okay, now I'm going to do something I'm not supposed to. I'm going to give you the graphs of the 6 trig functions. This is going to be fast, don't worry, I'll explain it later. But this will make things easier to understand with some of the material we have coming up. So this is extra. Sine, 1, 2, 3, 4. 1, 5 points. And sine continues forever with this pattern, but it ends at 2 pi or 360. And sine bounces between 1 and negative 1. Now, its buddy, cosecant, which will be in green, where there's zeros, there's these vertical asymptotes. So its buddy, cosecant, is really pretty crazy. But cosecant is just the green graph. Now, quickly, cosine goes 1, 2, 3, 4. Boom, 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 boom. But it does continue forever and ever and ever with that pattern. 360, 2 pi, 1, negative 1. And wherever they're, here, let's extend it one tick. It'll give you an idea what I mean by continues forever. But if you look where the zeros are, its buddy, secant, is the purple graph. Yep. High, low, low, high, forever and ever and ever has that pattern. Now, tangent I graph by itself. It's the hardest graph in my opinion. Tick, 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 tick. Zip in some verticals. Sorry, that's a really bad graph. Draw something that looks like x cubed. Approach your asymptotes. This distance is pi. 180. making this 90, making this 45, making this 1, making this negative 1. And that's the graph of tangent. Once again, I'm not even trying to make this nice. Cotangent looks very similar to tangent. You go 1, 2, 3, 4, drop in some verticals, do a point here, a point here, a point here, and approach your verticals. This distance is pi, meaning 180 degrees, making this 90, making this 45, and this is 1, and negative 1. And both the graphs repeat forever, meaning repeat, repeat, repeat. Probably just destroyed my paper. But anyway, on the previous page, we said cosine, all students take calculus, is positive in the first and the fourth, and negative. Well, the first quadrant is 0 to 90, and here happens to be 90. See how cosine is positive? Oops, sorry. See, get on the cosine graph, huh? See how cosine is positive? Now, cosine is negative in the second, from 90 to 180. From 90 to 180, cosine is negative. But wait, cosine is negative from 180 to 270. So negative from 180 to 270, and then positive again. Positive. Hey, yeah, we should use red for negative and black for positive. Now sine, well, the same for its buddy. Cosecant. Positive, positive, negative. So physically, that's what positive and negative mean. But that's not my dilemma here. I need to show you or somehow make you believe that sine and cosine are bounded between 1 and negative 1. So, if I graph sine, 1, 2, 3, 4, 0, 1, 0, negative 1, 0, instead of using the book's approach, you can see that sine is bounded between 1 and negative 1. Now, so you can't have a question like sine of theta equals 1.5. That's stupid. It can't, because it's between negative 1 and 1. Now, sine of theta equals 1, I even know where that is. It's right there when theta equals 90 degrees. Now, if somebody tells me sine theta equals 0.6 negative, I'm like, well, oh yeah, right there, right there. Do I know what the values are? I don't know. Nope. But there are two answers from 0 to 360, but unfortunately for you, there's more and more. Basically, the graph goes forever, so there's infinitely many answers. We'll deal with that later. But I had to convince you that sine was bounded between negative 1 and 1. And the cosecant theta is bigger than or equal to 1, because it's flipped up. And cosecant of theta is less than or equal to negative 1. So by looking at the graph, way easier to explain. Now the same with cosine theta, looks just like sine theta. And secant theta is bigger than 1. And secant theta is less than or equal to negative 1. So when they're asking all these questions, you're going to be able to look at the graphs and say yes or no. Like when somebody says, can secant theta equal 1/2? And you go, no. It's got to be bigger than 1 or smaller than negative 1. And if somebody says secant theta is equal to, you're like, well, it does. I may not know where, because I can graph cosine, and you will memorize these graphs that we're not supposed to be graphing now. The flipped over version, can secant equal to? Oh yeah. Technically, I got an answer in the first quadrant, and I got an answer in the fourth quadrant, but once again, we don't care about that right now. Anyway, those are the bounds on the secant, cosecant, sine, and cosine. On the other hand, tangent theta is less than infinity and greater than negative infinity. Tangent hits all the values from negative infinity to infinity. And cotangent of theta hits all the values. 1, 2, 3, 4. Da 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 da. Draw something that looks kind of like that. Cotangent, negative infinity to infinity. So the book has another explanation. I think mine's better. Granted, you should read the book. I really wish they would have put it in a different section though, or taught this thing called a unit circle first. It would actually make more sense. Okay, so I already created the Pythagorean theorem identities right away. The book goes into it now, that we're going to use the Pythagorean theorem to help us on a special book problem. Now, there's two ways to do this problem, and unfortunately, let me see where I'm at in my lecture time. Oh, we got this. I'm trying to keep them about 40 minutes. So here we go. Cosine theta equals question mark. Sine theta equals question mark. But I know tangent theta equals 4/3, and theta is in third quadrant. So, way one, the way I prefer. I am in the third quadrant. Now, you know, tangent is y over x, and my points in the third quadrant are negative and negative. So clearly, there must have been a negative there and a negative there. So, -4 for the y, -3, but the radius is the square root of -3 squared plus -4 squared equals 5. I am done, because I know cosine is x over 5, and I know sine is y over 5. I demolished the problem. Now, the book wants you to pretend like the Pythagorean theorem is like the way to go. It's not really what we use it for, but they're trying to get you to memorize the formula, so we can't fault them for choosing to use just basically work this problem the stupid way. But we'll do it anyway. They think it's cool. Way number 2. We know 1 plus tangent squared theta equals secant squared theta from earlier. So we got 1 plus, oops, what's tangent? 4/3 secant squared theta. Now we get 1 plus 16/9, which is really 9 over 9, which is 25 over 9, secant squared theta. Therefore, square root both sides with the square root method. The answer is secant theta plus or minus 5/3. But we're in the third, and it's all students take calculus. So in the third quadrant, only tangent and cotangent are positive, therefore secant is negative. Therefore, I know its buddy cosine, reciprocal buddy, is negative 3/5. But wait, we still got to get sine. So there's the other identity, sine squared theta plus cosine squared theta equals 1. So sine squared theta plus a negative 3/5 squared equals 1. That's 9/25. So 25/25 minus 9/25 is 16/25 equals sine squared theta. Doing the square root method, we get sine theta is plus or minus 4/5. But I'm in the third quadrant, and all students take calculus. Only tangent and cotangent are positive, therefore negative 4/5. Let me recap. Way 1, way 2. Let's learn our identities, do stupid little games, practice our all students take calculus, use our second formula, reuse all students take calculus. You can see they're just trying to get you to memorize stuff, think through stuff. I'm not saying it's bad, I'm just saying, well, boy, way 1 is the way to go. Now there's a problem 8, very last one of the day. I'm 2 minutes over, but let's do it. And there you go. Express secant theta in terms of sine. Well, secant theta, there's a bunch of ways you can do this, is 1 over cosine theta. But sine squared theta plus cosine squared theta equals 1. So cosine squared theta equals 1 minus sine squared theta. So just move that over. So cosine theta now, and theta's in 4. So secant in the fourth is all students take calculus. So in the fourth, cosine is positive, therefore secant's positive. So I did this work and I got secant to be 1 over cosine, and then I figured out cosine was plus or minus this. So secant theta is 1 over, going to here, not cosine. I got a choice, the plus it or the minus it, but I can't go with a minus because then it would make secant negative. Now, unfortunately, they don't let you leave radicals in the denominator, and it's unfortunate the way I showed my work here. So what you need to do, we will all pay for me being messy. Let's multiply by the world's stupidest one. 1 minus sine squared theta. 1 minus sine squared theta, which is the square root 1 minus sine squared theta. And the square root times the square root is itself. End of story. All right, you should have enough to read the section, go through it. Once again, trust me, this book is loaded. I know, So basically 50% of your reading I got covered for you. But there's all these nice interactive things you can do. Kind of recap my lecture before you start working their problems. So just give it some thought. I know you gotta manage your time, and you might have 8 classes, or you know, like me, I got my dog banging at my back door right now, and he wants in the house. So there's all these things that add up. But my model is listen to my lecture, take notes, uh, read the book, then do your MML problem assignment. And understand, once again, this is a very aggressive start. There's a lot in each section. Good luck.